Okay, so let's put this all together. Let's say I'm asked to find the trigonometric function of any angle in the plane. In this case, I want to evaluate the sine, cosine, of tangent of this randomly chosen angle, negative 855 degrees. How will I do it? Well, in this case, without a calculator, I would want to know my standard position angle. So let's do that. We're going to find our standard position angle between 0 and 360 degrees. So let's see. 360 degrees times 2 would be 720, but times 3, let's see, that is 1080 degrees. So what I'm going to do is I'm going to add 1080 degrees to get an angle between 0 and 360 degrees. Adding that gives me 225 degrees. Pardon me, I need to learn how to write these things. 225 degrees. Okay. Well, that's good because now I know we want to find a quadrant right here. This is going to be quadrant 3. It's greater than 180 but less than 270. So that means in quadrant 3 I need to find my reference angle, theta prime. Theta prime would be 225 degrees minus 180 degrees. Doing the subtraction gives me a reference angle of 45 degrees. All right, so we find our reference angle. We want to find the trigonometric functions that correspond to this reference angle. Well, we know that, for example, cosine of 45 degrees is square root of 2 over 2. Let's try that again. Square root of 2 over 2. The sine of 45 degrees is also radical 2 over 2. And that the tangent of 45 degrees is equal to 1. All right, that was one of our special triangles. But now we need to decide the sign that corresponds it. Well, in quadrant 3, we know that only tangent is positive. All the rest are negative. So, if someone were to ask you to find the cosine of negative 855 degrees, you should tell them that that value was negative square root of 2 over 2. For sine, same deal, right? The sine of negative 855 degrees, because we're in the third quadrant, will also be negative, so it'll be negative square root of 2 over 2. And then finally, for the tangent, if somebody asks for the tangent of negative 855 degrees, we should say that is positive 1. So knowing those values, we're done. That's exactly what we're looking for.